So recording has been started. As I said before, this call is being recorded and we will place our recording on our YouTube channel. If you're not comfortable with that, you can drop off now. Saj, floor is yours.
All right. Good morning, good afternoon, good evening, everyone. This edition of the Azure Power Lunch. My name is Saj Shashi, and I'm a cloud solutions architect. I'm based out of Dallas, Texas. I've been at Microsoft now coming up on about 3 years. Before that, I worked in both the telecom industry, so satellite as well as cellular. And yeah, I'm happy to be here. And today I'm going to be talking about um, the Azure Route Server. So I just wanted to be clear here. This is just an introduction. We've got 30 minutes, so probably wouldn't be able to go into a lot of details here, but just to give you an overview of what the Route Server is and what it brings for you as a user and a customer in Azure. And please stop me with questions in between. No problem. I don't mind being interrupted. Would love to answer your questions if I have those answers. If not, I'll get them back for you. Just wanted to start with an overview of virtual networks in Azure. So it's just going to be like a second, hopefully. But a virtual network in Azure is an isolated virtual data center. When you as a user start using Azure, you come into Azure, the virtual network is just an isolated data center. And you can instantiate and configure complex topologies in minutes, and it provides a lot of rich security and networking services. And as I mentioned before, undergirding all of this is Azure's software defined networking that allows you, your network is isolated, provides load balancing services, DMZs, bring your own network virtual appliances, Palo Alto, create your own user defined routes, excuse me, as well to route traffic the way you need to go. When you think about SDN, as most of you are aware, there are two separate planes. There's what's called the control plane, and that's how packets are forwarded, are supposed to be forwarded, and the data plane, which is the actual forwarding of the packets. So think of a control plane as your UDR or the route server, as we're going to talk about in a bit. Whereas a data plane would be like your NVA, your SD-WAN router that's sitting in Azure, or the VPN or Express Route Gateway. So the control plane will determine how it will get to its destination, but the data plane actually carries that traffic. So until now, the control plane routing in the virtual network was controlled by a UDR. So if you want to control routing, and say you have two different networks and you wanted to control routing to these two different networks, you create a UDR and then you assign that to a subnet, and then the control plane basically plumbs it in the Azure SDN, and the routing takes place. So what Azure Route Server brings is that it allows you to dynamically change routing within. So what does it actually do? So basically, it allows for dynamic routing between your network virtual appliance, what I call an NVA, and the Azure SDN using BGP. It's fully managed and highly available. So it's a PaaS service that you don't have to manage the VM running the software. And it also provides high availability. Zonal redundancy is automatically incorporated in regions where availability zones are available, I guess. And next is that it works in the control plane by automatically configuring your routes. So it allows you as a customer to make routing changes in the VNET or the peered VNET dynamically. Excuse me. You don't need to manually update the routing table on the NVA, and I'll show you an example of where this occurs as you use the normal hub and spoke architecture. You don't need to manually update the routing table on the NVA when the VNet changes occur in the spoke. And on the other side, you can peer with multiple instances of your NVA, and as well as it can be deployed in your existing VNet. Any questions here so far? Let me just show you
in the chat window, man.
Okay, please.
I said
thank you.
in the chat window. So
okay, perfect. Let's look at a standard configuration. This is it's not very common, but it's I've seen this in a lot of customers. So it's not very unique. And let's put it that way. So this is a network where you customer is has two connections. One using the Express Route gateway back to an on-premises, like let's say a data center, and then another one using the VPN gateway to like a let's say a branch office, right? In this case, this is like a very simple case, but in this case, you also have a single spoke VNet that is peered to the hub. So it's just a hub and spoke kind of architecture, a pattern, and the spoke is peered to the hub, and it's set up such that the peering is set up using use remote gateways. So this allows routes to dynamically be uh, uh, configured on the virtual machine's effective routing tables. Show you. So if you were to look at a VM's effective route, so the way you do that is go to the VM, go to networking, find the NIC card for that VM, and then you click on effective routes. It'll show you the routes that Azure SDN has configured for that particular network interface. So that's what determines how the packets are, where the packets are going to go, right? So here, as you can see, we have two on-premise networks, and uh, and the routes are plumbed in via BGP from Azure SDN. So there's no route server here, but what you cannot do here is that there are no routes being sent in on the on-premise side, on-premises one side, showing information about on-premises two. So if you wanted to send traffic from, I'm going to call it OP1 and OP2. So if you want to send traffic from OP1 to OP2, cannot dynamically send that across because there's no routes that have been advertised. So this is one of the things that customers have seen when they have both Express Route gateway as well as a VPN gateway sitting in a hub VNet. They cannot send dynamically create routes. Obviously, you could create a route, create some static routes, but on your side as a customer, but dynamically it is not available. So so this is one of the problems that the Azure Route Server solves, where the Azure Route Server would sit as, I would call it more like a route reflector. It's in the control plane, so it's in the control plane path. It's not in the data plane path. So data is not being sent to the route server, but it peers with both the Express Route gateway as well as the VPN gateway, and it forwards the routes accordingly. So now you have, as before, the VM effective routes are still the same, but now dynamic routing between on OP1 and OP2 is possible. I'm going to pause here for like a couple of seconds just to see if anyone has any questions. Right. Um, let's take a look at another scenario, another pattern. This is where I worked with a customer, with one of my customers, and where they had an SD-WAN network and they had Express Route gateway. So again, here the network NVA, I think here was CSR, but or possibly something else. I forget now, but worked with a few customers, Silver Peak, whether it's CSR, Cisco. Either way, again, when you need, excuse me. So when you a route must be manually added to the NVA routing table each time you add a spoke. Let's say you're going to add another spoke up here. When you add that spoke, you have to go to the NVA, add a route from the routing table so that there's you could connect both ends. The second thing is that if you add another spoke, a UDR must be manually updated each time you add a spoke subnet. So I'm sorry. So let me repeat my. I was incorrect. So if you add a new spoke here, you'd have to have another UDR. So um, let's say you add spoke 2, you need to manually create a UDR to allow routing back. And then if you um, each time you need to make any changes in the SD-WAN, you have to manually add something here in the routing table as well. Those are the those are the two things which you have to make manual changes, right? And again, as usual, as before, there's no dynamic routing between the ER gateway and the NVA, so you cannot send traffic back and forth, right? And this is what the Azure Route Server solves, right? It peers with both your NVA, it peers with your Express Route gateway. And in addition to that, it also knows when you add another spoke. Okay. So it allows you to dynamically exchange routes via BGP between the NVA and the VRs and the route server. So anytime any new routes are added, the NVA can automatically send that and advertise that, and the route server will advertise it to other peers as well. Effective routes will automatically be updated by the route server each time changes occur in the NVA side, on the SD-WAN side. Now, when you add a new spoke, routes get dynamically updated and they'll be sent to both the on-premise as well as the SD-WAN network. So now you can reach the spoke without without having to create any manual routes. Any questions here? Okay. I'm going to show you a little demo. Based on this network diagram, I'm going to show you a little demo here. So as you can see, I have a CSR that's connecting to the SD-WAN side. So I call that branch 2. I have a VM, a Linux VM sitting in branch 2. Obviously, all of this is in Azure for my testing. I have a hub. I have a VM sitting in the Linux VM sitting in the hub. I have a spoke 1, as I showed you before, and there's a Linux VM sitting there. And then I have a second spoke, which I have not peered to the hub as yet. It's just a standalone spoke. So I call it spoke 2, and I have a VM there as well. And branch 1 is a VPN connected branch. So that's using Azure's VPN gateway. So it's a regular VPN connection. So instead of the ExpressRoute gateway, I have a regular VPN gateway, and I have a VM sitting there as well. Right. So if you were to look at if you were to look at my current configuration here, are you able to see my screen? Okay.
Yeah, you can.
Okay. So here I'm pinging from this is the Linux VM sitting in branch 1. I'm trying to ping I'm trying to ping the spokes. I'm trying to ping branch 2, and you can see here, I can. Sorry, I have a bastion running here, and it doesn't well on the screen here. So okay. So I ping my hub VM, no issues. I ping my spoke 1 VM. This is from branch 1, no issues. Spoke 1 hub, and I ping my branch 2 VM. So my branch to branch traffic works. My branch to hub traffic works. My branch to spoke traffic works. But since I don't, if you were to look at my the configuration, as I mentioned before, I do not have, if you were to look at the spoke VM that I have here, that's sitting in spoke 2, it does not have, it's not peered. So if you were to look at the hub is only peered to spoke 1, right? And if I were to add the peering here, say, hub, it takes a little bit of time, and hopefully I'll go back again through the. This is my hub. I'm sorry, this is my spoke 2 VM. So take a little bit of time, but anyways, just to go back to what I had before, start my script that starts pinging all the VMs. So as before, I'm able to ping spoke 1, spoke 2, still not spoke 2. Now I can ping spoke 2 from, if you look at this here, I can dynamically, it has dynamically been updated. So if you look at this, well, hub 1, spoke 1, and now successful. Same way. Again, this is from spoke 2. I'm pinging all the other VMs. I'm able to talk to branch 1, branch 2, and the hub. Hub is obviously very easy because I'm just simply doing a peering. But with the others, you can see the routes get dynamically updated. Any questions here? Back to when I added the new spoke, these routes dynamically sent back into both the SD-WAN side as well as YARN. So what are some of the caveats in deploying the route server? Must be deployed in a separate subnet with and you have the name of the subnet has to be route server subnet. Route server subnet cannot be associated, cannot have an NSG or a UDR associated with it, right? It must be assigned a public IP, and many people ask why is that, and that's because for management purposes only, so it's not externally accessible. And as I mentioned before, it will be zonally redundant if deployed in a region that supports availability zones. So if you deploy it in a region that doesn't support availability zones, it will create uh, two route servers, VMs underneath, but be zone redundant. And the next is these are some of the common issues that we have run into. This is some of the things that I have run into when I've been playing around with it. So for traffic between the express route to the VPN or SD-WAN side, you have to make sure that you enable branch to branch. If you don't enable that, route server won't reflect those routes between the two, right? When using branch to branch with VPN, so especially Azure VPN, especially with Azure VPN, it must be set up in active mode, and the ASN must be 65515. You cannot change that. Remember that the Azure route server is in the control path and not the data path, so it's not like a traditional router. It's more of a reflector, so it's reflecting the routes, but it's not doing any traditional routing, right? It's the standard BGP and everything else, but it does not actually forward the packets. Currently, one of the issues that we have is that express routes are always preferred over VPN, even when you advertise a shorter AS path. So if you need to choose, so if you have, let's say you have two paths, one over express route to your data center and another path over VPN, and you want to prefer VPN over express route, then you have to advertise a more specific route to choose the VPN path. But if you do something like a shorter AS path, that's not going to work. It's hard coded currently that the express route path is preferred. And then this is one of the ones that we ran into. I spent days before I figured out this cannot work, is that you cannot peer two route servers between peered VNets. So basically, if you have region 1 and region 2 and have route servers sitting in each of those regions, you cannot peer route servers between those two regions so that you can connect to NVAs. So there are more complex scenarios, and I'll have links in my document, which we will send out, but those scenarios are covered in those more advanced scenarios. And a couple of the other ones that I have noticed is that this is another common one. So you have to override the default route. So if your NVA is advertising a default route to the route server will program those routes in all the VMs in the VNet, including the NVAs. So the NVA's packet, even though the NVA thinks it's sending it to the right destination, it'll go out and then it will come back to the NVA. You're kind of like, I don't want to say routing loop, but it loops back over and over again to the NVA. So to avoid that, this is a very common mistake. To avoid that, make sure you are create a UDR and assign it to the subnet that the NVA is in. Not very common, but we noticed this in we noticed BGP flapping when peering with when using like an open source based routing server like Bird running on Linux, and where if you do not create static routes to the route server subnet, then it would static routes in your BGP, then it would cause issues. I'm sorry, static routes in your Linux VM issues. I've only seen this in Bird. I've not seen it in others. This is also sometimes happens. Any questions here so far on the issues? Okay. And lastly, I just want to show some links here, and this will be again in the document that Keith will post. Most of what I've learned about route server and pretty much networking, the advanced networking in Azure has been from these folks here. Great folks to work with. I've worked with Daniel, Heather, and Jorge um, one-on-one, and they're just great folks who have helped in my understanding of Azure networking, and especially they have created some more complex and advanced scenarios using Azure Route Server. So if you don't want to use Express Route Global Reach, but want to use Azure Route Server, you could do that. And there are some labs there. So I would recommend going to these links for more complex kind of patterns, design patterns. And then obviously Mark VPN as well as he's got a wonderful virtual WAN lab that I would recommend as well. But I used his Azure Route Server lab to kind of quickly create my environment to show you what show you the demo here.
Sajid, there's a
Yes.
question in the
Mm-hmm.
chat window. It's Troy's asking, would that also include transitive routing between the spokes without a UDR?
Transitive routing, no. So the transitive routing to the spokes, you would have to create UDRs. Yes. Normally, in normal customer cases, transitive routing, so going to the hub and then coming back is you would have to create a UDR. So a normal design pattern is that when you have a hub and spoke architecture, your default route, which I didn't show in my effective routes, but you would have to have a UDR with a default route pointing to the firewall, some kind of firewall, especially if you're inspecting packets. And so the firewall so it becomes a little bit more complex. And I would recommend in this to look at Heather's multi-region hub and spoke with the ER bow tie. I mean, it has the ER bow tie, but also has um, concepts of this question. And you would create a default route to the firewall, and the firewall would decide whether to route it back to the other spoke. So normally, I've seen customers they don't want inter-spoke traffic unless for a specific reason. So that answers your question.
Does that answer your question? I mean, if not, please speak up.
And aside of that, I mean, I could quickly show actually this is Heather's link, so which is again going to be in the documentation. But yeah, this is you can if you have your default route set to the Azure firewall, and then you create the allow or deny. But I would recommend all these links that I've shared. They're really helpful in doing those advanced scenarios. Some of it is that I don't have an immediate access to Express routes, so that makes it a little bit more recommend. There are no more questions I have.
I don't see any other questions in the. Yeah, Troy said he that answered your question, so I don't see any other questions.
That I'm going to stop sharing.
So folks, any other questions, please, if you have, feel free to open mic and ask or post in the chat window. If not, thank you everyone for your time for joining the session, and thanks Saj really for this is I did not know much about the route server, but after this, I think I know more than what I know before. So it's very helpful.
Absolutely.
Thank you.
Yep.
Thank you very much. And I hope to give everybody the 3 minutes back and look forward to see everyone in another session of Azure Power Lunch. Have a wonderful weekend, everyone.
Thanks
You
all.
too. Thank you.
Thank you.
Cheers.